Hi guys, this is Glenn checking in with you. I hope you've had a chance to make some good progress on your models and have your foundation systems and your wall systems in pretty good shape. Today we're going to take a look at some of the final elements in terms of putting together your models. We'll be looking at the framing of roof systems and sort of the related issue of framing of the floor systems. And we'll also be taking a look at how to model some custom furniture and just some custom elements that were sort of were common in a lot of Schindler's houses, where he was creating sort of very custom elements to match his very custom geometry. So to get started with today, we're going to start by looking at a couple of different ways of framing up roof systems. And we'll actually start by looking at kind of three main ways that Schindler was using as we sort of follow him through some of the different houses. The first being a system where we actually have sort of planks on top of an open beam system, and this was kind of typical of the kind of Schindler frame and the Kings Road houses. Then we're going to be looking at a couple of what I'll call joist systems, some of which are exposed, so you can see the joist from the underside, some of which are closed, and you can sort of see a progression of Schindler's construction techniques as we go moving through these different systems. So let's go ahead and get started. Okay, to get going, let's go take a look at a detail of the Kings Road house and the Schindler frame and just try to understand really what those systems look like. So if we go ahead and open up kind of classic section view of the Kings Road house, here's what we're looking at. If we take a look at this detail, we can see that there's actually a system of beams. For example, these 3x8 joists running at 24 inches on center, okay, carrying the actual roof. The roof is actually made up of 1x8 planks resting on top of those joists. Okay, then on one end, that's all being supported by the concrete walls. It looks like what's happening over on this side, there's actually a little bit of a ledger, maybe about 1x8, which is anchor bolted into the concrete wall, and that's actually carrying this into the joists. And over on this side, these look like their beams are actually being carried to the joists. I'm using those two terms pretty interchangeably. Are being carried by a 3x8 beam on the end, which is then sort of on top of a clear story window and ultimately supported by some 3x8 posts down below. And those lower beams are at 6'3", the upper beams are at 8 foot at the bottom. Okay, so that's kind of the basic idea of what's happening here. If we take a look at the details for the Schindler frame, you'll actually find sort of a very similar sort of system where we have these beams. In those cases, we modeled them as 2-bys, I think they were, coming up from the soffit level and actually supporting the planking at the roof level. But the idea is there are some things which are either beams or like soffit elements which are supporting the planking, and there's really just an open system where you can actually see the bottom of the planking and the top is covered with like a tar and gravel sort of roof. A little bit of a fascia detail here at the end also, just to kind of like protect it so you have a little more thickness at the end. You have an opportunity for actually the rain to run off too, and yeah, can have a little bit of drainage on the sides. So that was typical of some of his early roofs. So let's take a look at how you could model a system like that. If I go switching back over to Revit and start placing some things, let's go ahead and I'll pop out to 3D for a second so you can sort of see what we set up. We have a series of, these are just those Kings Road wall panels kind of hanging out, just waiting for us to go through and start putting some framing in there. And if I start with that system and go to level 1, you'll see I've actually set up some grids that are sort of matching the breaks in the wall panels, which would probably be a very typical thing for Schindler to have done. He really liked his grids. To go through and create some of those basic beam elements, we could do things like put in some structural columns. And for those structural columns, we don't have, by default, wood frame ones loaded. These are wide flange columns, steel columns. So what we'd probably have to do is load in some families. And if we go to the structural folder, and go to columns and open wood, we'll find some dimensional lumber. If we open that up, we can go through and choose some specific sizes that we're interested in. In this case, we'll go for 3x8s, and maybe I'll go for like 2x8s. Just really kind of collect as many different sizes as you think you're going to need. And I'll warn you about these. These are actually, what are these? These are dimensional lumber sizes. What's going to happen is the lumber that Schindler was using, looks like he was calling out sort of explicit sizes as opposed to nominal sizes, so we might need to do a little bit of adjustment to those. So we have, for example, these like different column sizes that are available. If I open up the 3x8, you'll see that it actually isn't 3x8. It's really a more modern standard of being nominal sizes. So what I'll do is actually create a new one. I'm just going to call it 3x8 true dimensions, just so I could actually match what he was using at his time. So 0 foot 3 by 0 foot 8. Okay, we'll go ahead and place some of those different columns. Let's take a look at how you do that. We're going to sort of place them from the bottom up. So I'm going to go to, in this case it looked like, oh, we were going to go to just relative to level 1. What's interesting, it's going to fight with me a little bit just over the issue of really how high I can make them. Maybe I'll leave them to soffit right now and change that a little bit later. Okay, that's going to be fine. I'm going to put them at the grid intersection, so I can actually just choose some grids. I'm just selecting them. And then I'll select this grid also, and control clicking to select those. You'll see it's actually sort of rotated them in the wrong direction. If I hit the space bar, it'll rotate them around to the right direction. And I can say finish those. Okay, and that'll at least get those in place. Now, note that they're a little bit off in terms of their heights right now, because it wouldn't let me sort of adjust it right as I was putting them in at first. Let me see if I can get it in here now. I'm going to put in an offset of 6 relative to level 1. Okay, and I think that's going to match the detail that we saw in the drawing. So about 6 feet. Oh, I take that back. 6 foot 3. Let's go back and fix that. So again, I'll choose all those. And I'll say that you are all 6 foot 3 off the floor. Okay, now we need some beams that are running across in the other direction. To get that, what I'll do is go again to the Structure tab and choose the Beam tool. In the Beam tool, again, you'll see we have some standard beams loaded, but not the ones we want. We're going to actually load in a dimensional lumber and make it a true 3x8. So we'll say structural, framing, wood, dimensional lumber, and I can now go through and, let me just choose those 3x8s. Again, I'm going to adjust it to be a true 3x8, so I'll duplicate that, true dimensions, and change it to 0, 3, 0, 8. As I'm placing beams, beams are always a little bit tricky to place, so watch out for this, because what typically happens is when you place beams, you're actually placing them above your head, because they're typically above the level of 4 feet where the cutting plane typically happens. So let's go ahead and shift around a little bit. Rather than looking at the floor plan view, what I'm actually going to want to do is look at the ceiling plan for level 1. That way I'm going to be looking up instead. I'll choose beams. I'm going to say that I'm going to put these at, what is it? Let me go ahead, and there's a number of ways I could go ahead and dimension this. If I say relative to level 1, what I'm going to do is offset the top of them. No, the tops aren't at level 1. Let me do this. Let me say other, I'll call it, what 6 foot 3 was the bottom, so 6 foot 11 will be the top. Let's try that and see how that works. We'll say OK to that. And then what I'm going to do is just draw something that goes from here to here. Notice it's again going to warn me that we can't see those elements. That could be for a number of reasons. As we're looking at trying to put beams in, we do have to go ahead and turn the coarseness up from coarse to a finer level of detail to see them. But that's not what's causing it in this case. I think what's probably happening here, if I look at visibility graphics, you'll find that in most architectural drawings, the structural framing is turned off. So I might have to turn that on to be able to see the beams. Still not seeing them, so let's take a look in 3D and see if I can see what's going on. Looks like they are showing up there. And if I look at them in section, I think they're showing up in there. Again, I need to turn up the level of detail. That's not looking too bad. in terms of what's going on. Some of the different things we want to do just to kind of make sure we get these all adjusted. One is we do want to go through and, if we're going to follow his detail, align, if you look at it, the back of the columns, okay, with the beam, so it's actually lining up sort of more on the back side. So we could go ahead and say align, that'll be AL for align, or let me try the modify tool. See if I can choose that beam. And again, we will do an alignment right there. Choose this, bring those back, let's lock those in place. That's not looking too bad. Now for this next one, let's go ahead and we can even try just copying that up. Let me see if that'll work. I'll copy this, take it on up. That was actually pretty easy. Looks like I even got it about the right location, which is going to be the Z direction off it, so right at, it's 6'11". Well, I'm going to take that back. That's off the soffit level. Let's go ahead and, oh, there's a lot of ways we could reference this. Let me just say it's going to be, I believe it's level 2 was our roof here. We're just going to check to see what's going on over there. No, it's top of the concrete panels. That's what's actually going to be the top of our roof over here. So top of concrete panels. And I'm going to say that the top of these beams is just, I'll change that offset. That's if we want to have the sloping. Let's see how that looks. Now that's actually looking pretty good. Maybe I'll move that away so you can sort of see the section a little bit better. Okay, we're actually doing pretty good now because we do want the beams that are in the roof to go ahead and line up with that top of the concrete panel. Let's go back to 3D. So over on this side of the wall, though, we're going to want to do something a little bit different. If we go through and take a look at the beams, you'll see that they tie in at this side to this little bit of a ledger element, and I was guessing that was probably about a 1x8. So to model that, we could do something like, again, go to structural beams, structure in beams. In this case, I'm going to create something like a 1x8. Okay, that'll be 0'1" by 0'8". That's looking pretty good. Now in terms of placing that ledger, let's go ahead and try and use some 3D snapping to actually place it at the right level. What we want to do is actually place it at the top of the concrete panels, and the top of it will be at the top of those panels. So what we're going to do is just use the pick line, and I'll click right on, if you zoom on in, that inner edge, that's where I really want it to be. Let me orbit this around just a little bit so we can kind of take a look. It looks like it's actually doing a good job. We can pan that a little bit too. Actually, this looks like it's actually recessed into the wall. That's not quite what we have in mind. So what I'll do is I'll choose that, and you'll see that in addition to the Z-level offset, you have this lateral justification. And we can decide really what side of the beam lines up with the line that we picked. It looks like it's going to be side 2. Okay, great. Now it's on the inside as opposed to the outside. So having placed that one, we can actually just stretch that right along and get a ledger that's running across the entire distance of that wall, across all those different wall panels. Super! Okay, now that we have those two things, we're ready to start placing the beams that are cutting across in the other direction. Those are going to be beams also. These are going to be the 3x8 beams to the true dimension. Okay, let's again think about where they're going. They're going to be at the top of the concrete panels. That's the top level offset, so try and get the properties all set up. In fact, let me move this over here just so it's easier to see. So we'll get the top of them all set up, or the properties all set up before we start placing them. Okay, once we have that in place, let's go through and, we can place it in a number of different views. Let me go back to that ceiling plan view and see if we can do it that way so we're looking up as opposed to down. We'll go back to the beam tool. And once again, being careful to choose the right placement plane. It's going to be top of the concrete panels, top of the beams at that level, centered. Let's see if we can place these. Okay, that's looking pretty good. Now, if we have those in place, let's just kind of confirm it in 3D, and that's actually looking pretty good over here. Okay. What we want to do now is, although, well, they're a little bit long. Let's go ahead and fix that before we go ahead and copy these up. I will say that in terms of the joins, we don't actually want them to join this way. We want them to actually join in the opposite direction. So let me see if I can adjust that. Beam joins are actually handled right here. That's wall joins. Beam joins are right there, very close to it. I can sort of adjust the directionality of where, or how they want to cross, in like which is going to be the dominant element versus the subordinate element. So I can get that adjusted. Let me do the same thing over here. I'm going to say that really this one pulls back and that one pulls down. Okay, now they're adjusted the way I like. Okay. Now that that's in place, let's escape. And we can take these, and what we're going to do is array those. Since we need to go through and basically create a bunch of them at 24 inches on center, I can go through and either array these or just copy them. Arraying is often the easiest way to do that. So I'll choose the array tool. I will grab this, spread out 2 feet, since they're at 24 inches on center. Okay, then I can actually put in the number of them that I want to go through and put in here. Oh, let's put in 10 of them. I thought I got 10. Let's try again. It's off the screen there, but 10. There we go. Maybe we need more. Let's try 18 of them. Okay, but that's how we go through and create very regularly spaced framing elements. Let's go ahead and save that. There we have the basic system. And now we have the framing in place. What we're ready to do now is actually go ahead and start putting the roof surface on top of it. For the roof surface, let's go back and look at our detail. We're looking at 1x8 planks. Here they're overhanging just a little bit. Over here they're just right about to it, but we have a little bit of a fascia detail. So let's kind of take a look at how we could create that. To create the roof, it's going to be very much like creating the floor elements, where we have a multi-layer assembly. And what we can do is choose the roof tool, roof by footprint. And what we're going to start by doing is just creating a roof that has the right elements to it. And they have a couple of ones that we could use as a starting point, but really just going to take one and duplicate it and see if we can come up with what we like. I'm going to call this just 1x8 planks with tar and gravel. And what the structure that's going to look like is something like this. Let's say it's going to be 0, 1.5 for 1x8, or actually his dimensions probably, or not, see that, excuse me, 0, 1. We don't have a layer sheathing on top of that. But then in terms of the actual asphalt, or the material on top of it, this is set up to be asphalt shingles, 1/4 inch thick. We can go through and change these materials to be something closer to what we want. Oh, let's see what we have here in terms of roofing. Membrane. Let's just take that one, we'll duplicate it. We'll call it roofing gravel. And we can give that a nice surface pattern. That would show up in like a 3D view. Let's shift to a model-based category. That'll be probably a little bit better in terms of having something that looks grainy. And take that back. Let's go back to drain. Oh, there we go. I'll do something like, oh, like the dense sand, something like that. Let me pull that up so you can see it. And then over on this side for the structural wood, again, one of those ones where we just want, could be like floor planking. In this case, though, it's going to be the roof planking. So we can just name that. And creating separate materials is going to give us the ability to go through and like change the visual appearance if we need to, okay, between the roof and the floor. So you might as well get that set up now so you're ready for it in the future. Great. Okay, we have something that's about the right level. Now we're ready to place it. The important thing to keep in mind as we're placing roofs is they actually sort of sit on top as opposed to floors which are below the level where you place them. So roofs always sit on top. And let's think about how that's going to relate to our detail. So it looks like if the top of the concrete walls, the top of the concrete panels was right here, it looks like the planks actually just go right on top and sort of extend beyond. So what we can do is, kind of in the same sense, let me do it in, about, can I see that in the top of the concrete panels? I can't exactly. What I really want to do is actually be a little bit higher still. Maybe I'll do it in the ceiling plan, so I can sort of see them in there. I'm looking up now, so what I'm going to do is just draw that footprint, and I could do that by picking lines or picking walls, whatever is going to be necessary. In this case, let me go ahead and just sort of pick some lines. I'm going to pick it to the outside of that one. I'll pick it to the outside of that one. I know it's going to actually extend a little bit further. Relative to this wall over here, we have the issue of how far out it extends beyond the edge. And it looks like it does extend a little bit. There's actually a little piece of trim that's in there that's kind of doing it, or filling in the gap. Maybe extend that a few inches beyond. So I could say over here, let's do an offset of maybe, let me extend it about 3 inches beyond on this side. And on this side, I think it's actually going to be just right about even. With the edge of the beam, which actually happens to be almost just exactly right on the grid line too. Okay, now I've set 4 lines in place. What I want to do now is, rather than trying to like gather all the surfaces, I'm going to use the trim tool to just define that with only 4 lines. That'll be a little bit neater in the long run. So if you can, rather than trying to select every individual piece, which sometimes makes it hard to go through and get a continuous boundary, just use the trim tool if you can to close that up. Final thing will be, let's go ahead, grab all those and say they don't have a slope to them. Finish that up. Let's take a look in section. Looks like I may have them in the wrong location. Let's take a look, see what's going on here. Oh, I'm looking at the wrong section basically. Let's come over here. That's looking a little bit better. You can sort of see those things in place. That's looking pretty good. So those are actually looking not too bad right now. You might have noticed there's the tar and gravel on the top. That's looking pretty good. But in the ceiling plan, we have this issue where it looks like my plank direction is running sort of almost in the opposite direction of the way I would like it to be. I'm just going to shade that so you see that. What you can do is you can tab and actually just grab one of the pattern lines, then rotate that. I know it sounds a little bit counterintuitive, but it will rotate the pattern. Shift it 90 degrees, and that is very similar to what you need. It's also going to be very similar to what you want to have happen just in the, let me go ahead and set this up like in a perspective view. So I'll put a camera in there just so we can sort of see. That's one of the reasons for modeling it so carefully, is that we can go ahead and take a look at that. And that's not looking too bad. Say consistent colors. Maybe even here. I'm going to move down a little bit. It's kind of funny. It's such a low roof, it's hard to see the effect. That's the architectural effect we had in mind. And that's actually very consistent for a lot of the Schindler houses, as well as a lot of homes. Eichler homes, a lot of homes got built in the sort of post and beam with a plank style. And that's just kind of a very appealing look. Now to complete our model, we should go ahead and incorporate one other small detail. And that is that there's actually a little bit of what I call a fascia that's around the edge of the roof. And let's take a look at what that looks like. Here he's showing it as a 1x4, standing off a little bit. Here, it's a little bit hard. I think it's also probably a 1x4 over there. Well, it's called out 1x2, but again, it's standing off a little bit. And you even see that in the Schindler frame. Yeah, he has in this case it's 6 to 12 inches, but it's a fascia board that's standing off from the edge of the roof a little bit. Again, kind of providing a thicker appearance around the edge of the roof and giving a little sort of space where actually drainage is going to occur. So let's talk about how you can model that. If we go back over here, and I'll go out to a 3D view from the outside, you can sort of see here's our basic roof, and let me orbit it around. So you can see, oh, it's really this raw edge is what we're trying to avoid right over here. It's just kind of a small edge right now, and we'd like to sort of fatten that up so it has a little more architectural prominence. So what we're going to do is go through and add something else in that's a roof feature called a fascia. Fascias are pretty straightforward. We sort of had baseboards and other types of sweeps, and this is really going to work the same way. They have some fascia profiles like a 1x12. That's kind of not exactly what we have in mind. We had more in the idea of like a 1x4. So how we can sort of make that happen is go on down to the profiles. It should start looking familiar now. And in the profiles, there's fascia. Well, looks like we even have a 1x4, so we don't have to create a new type or a new profile. We will go through and create a new fascia type. And to do that, we'll say roof fascia. I'll edit this existing type. I'll make it a 1x4 fascia instead. And the big thing we have to do is just change the profile. Could get it a material if we want to. Say OK. And now we're going to go through and place it. And to place it, what I really need to do is just click on the line, kind of like what I did with that ledger. I'll just click on this line. Okay, that placed the fascia there. Now if the fascia is not exactly where we want it to be, we can give it a little bit of horizontal offset. That's what he did. Oh, let's call it maybe 2 inches off. That looks a little bit too severe. Maybe only about 1 inch off. And we could also give it a vertical offset. Let's check this out. So in his detail, looks like he's actually sort of about the top coming down. In the Schindler frame, I think it's a little bit different. Here it's popping up instead. So really whatever is appropriate for your house. You can go ahead and give it a profile offset. Oh, let's say maybe 3 inches. Pop it up instead. That was a little too severe. Maybe 2. But that's giving us that thicker appearance and giving you a pretty accurate model of how we did these kind of plank roofs over an open beam system. So that's the first example. Next we're going to go ahead and take a look at how we can do something more like a level beach house where we have joists, but we have a sloping roof and maybe even close off the joists on the bottom. Actually, before we go jumping over to level, let me kind of show you one other variation, because the same basic notion can be used to model floors when we want to see the floor framing too. And a really good example of that is actually in the Revit sample house. So if you go to the sample house, which is available just in all the Revit installations, it looks something like that. Let me zoom that to fit. And if you open up, there's a really good view that shows what I have in mind. It's called the sectional perspective. You can zoom on in, and you'll see, if I pan that over a little bit, that here we have a very similar thing going on. We have this open beam system up here at the roof level, made up of, again, just dimensional lumber pieces. These are all metric, that's why the sizes look a little odd, but at a regular spacing. And down in here, here's the floor plane, and the same thing is happening. We have just the open joist elements and a very thin floor, just a finished floor on top of that. And again, that's something you can use for your floors if you actually want to start showing that structural framing and illustrate that so you can see the true structural skeleton of the house.